Hello and welcome to this CDACC question, or if you like to call it um, a marking scheme. So this is question number 15 in section uh, section B. Section B. This is a question that was done in 2025 CDACC. It is a paper for building technology level 5 CDACC 2025 technical drawing or applied drawing. So before we tackle this question, let me just point out that the question was not very clear. If we can go through it, question number 15. Points in a mechanism can be traced if there is a movement of a point rotating and making a revolution. Part A, link mechanism crank AB is connected to link BE, which is constrained at D, where AB is 35, BD is 100, and BC is 65. So we shall start by correcting the link mechanism AB, which is, let me just point the link mechanism. In this link mechanism, the whole of this is called a link mechanism. Just the connection between all these parts is called a link mechanism. But now we are singling out the crank, which is AB, crank AB. Here is given as 35. Then we have is connected to link BE. So we can see this is the link BD, which is indicated here as BE. So we can simply change this to BD, link BD, which is constrained. It is constrained at D. What do we mean by being constrained? It cannot move. It cannot move, but that's not the case. That's not the case. It is constrained to move along this line. It is not constrained to be at that point, but to move along this line. That means it cannot move up or down or any other direction, but can only move through this line. So this is a sliding part. It is a sliding part, even though it must also have a pin joint to make it possible to move. So let us see the correction. So in the correction here, we can see that the link mechanism, in this link mechanism, AB, just the same AB, which is 35. That means that this circle is the locus traced by point B. The point B will be rotating within this circle like that. Yeah, so it is pin jointed at A. B moves around the circle, and the crank is pin jointed at A. So that's understood. Uh, it is connected to link BD. Now we can see that this is B and this is D. So we know that this is the link. This is the link. It has a midpoint here, and this midpoint is located BC. So BC is 65, right? And then which is constrained to slide in the direction. So now the correction is here. It is constrained to slide in the direction. This is the direction XX. The direction X on this side and direction X on this side. So this D can only move along this line like that. Okay, so with a pin joint at D, so we cannot fail to point out that the connection between this link and this gadget that enables it to slide through this line, what connects these two components together is a pin joint. It is a pin joint in the direction of the pin joint. So these ones we had gone through, and we know that AB is a crank 35. So this circle is also 35 radius. The circle is 35 radius, and then BD is 100. BD is 100, and BC is 65. So we have all the parameters together, and we can now tackle this question. So what's the question? Draw the locus of point C. Even though we have the locus of point B, this locus of point B is only going to help us to trace the position of B, C, and D at any particular time. So what we need here is to see the movement of C. So let us go and see what we can do. So as we say, the first thing here is to draw the circle. The first thing is to draw the circle with a radius 35 millimeters, and this circle represents the movement of our crank, but this may not give us anything without dividing this circle into 12 equal parts so that we may be able to trace 12 movements, 12 movements of the crank around A, the crank B around A. So here we have done the division. We have divided the circle. Two methods of doing it. In one method, we can use a pair of compass. Just stretch your pair of compass 35 millimeters and draw the circle, and uh, uh, then divide the circle into quarters. Divide the circle into quarters. How do you do that? Just use a T-square to draw this horizontal line, and then T-square and Z-square to draw this vertical line, and you have the quarters. So with your pair of compass stretched 35 millimeters, you can stand here, strike on the upper side, and strike on the lower side. It will give you this point and give you this point. Then you come here, you place your pair of compass here with the same stretch of 35 millimeters. You will strike this, and it will give you this. Then you come here, stand here with your pair of compass. You'll be able to strike this and strike that. Then you come here and you'll be able to strike this and you strike that. And for those points that you have marked, now if you draw a line passing through the center, it will be able to touch the other mark that you have done there, and this will be an angle of 60 degrees. Next will be an angle of 30 degrees. And if you do that, you've already marked this and that, point this and that, and you've marked point this and that. Then next, you come here, and this is a point which you marked when you're standing here with your pair of compass. You mark this and that. Therefore, you can now pass this through the center, and you'll have another point there, and that would be 30 degrees. And if you mark this one, that will be 60 degrees. And if you go all around, you end up having the 12 equal points. If you count these points, each quarter will have 2 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 points. And that means that you have managed to divide this circle into 12 equal parts. Next, you can now name the points. Name the points. I started with B1. You can name it anyhow, but just for convenience, let us have all the parts being named B, and then B and a number. We'll allocate it B because it is point B that is moving all through. It is the same point that is moving, but now we are tracing the movement with numbers. So this is the first point, then it will move B2, and then it will move B3, it will move B4, B5, B6 until we reach B12. That gives us 12 equal parts. So next we shall elongate this this B3. We shall elongate it so as to find the line in which our D will be constrained. So our D can only move along this line, either in this direction or this direction. Our D will either move this side or this side, which is the direction X and the direction X. Remember, all these lines we have drawn up to this moment, they are all construction lines. Nothing here will be drawn in finished line. Nothing should be bold, nothing should be dark. Everything should be light. Yeah. So let us now start our movement. Because we have been told that our link BD is 100 millimeters. So you pick your pair of compass and measure 100 millimeters, place it at B and strike along this line to get our D1. So remember, we have B1 here, D1 will be there because that's our first marking. Then again, stretch your pair of compass 65 because BC is 65. So stretch your pair of compass 65, place it here and strike C. So B1, C1 is 65, B1, D1 is 100. Yeah. Then we go to the next one and we stretch our pair of compass again 100, place it at B and strike along this line. You get your B2 and then connect B2 and D2 with a line, and then also measure C1. So you will do that for every other. So this is B1, B1, D, B1, B, D1, then B2, D2, B3, D3, yeah. And once you get that line, you must also mark your C. You mark the B, get the B, from B, stretch 100 millimeters. From B, stretch 100 millimeters, strike along that line, you get your D. And once you get your D, again go back and stretch it 65 millimeters and get your C. Yeah. So you get your B. From B, you get the D by stretching 100, and then get your C by stretching 65, and you continue like that, B5, D5, and you will notice that every two, because this diagram is symmetrical, yeah, that this center line is the constraining line. This center line is the constraining line. You will find that B1, B2, and B4, B2 and B4 will strike at the same point on D. So D2 and D4 are at the same point, but D2 is on the upper side and D4 is on the lower side. Same to D5 and D1. So D5 coming from B1 and D5 coming from B5, though both of them strike at this point. So D5 will be on the lower side and D1 will be on the upper side, but they are striking the same point here. Same to 12, B12 and B6. If you come here, they will strike at the same point, D12 and D6, D12 on the upper side and D6 on the lower side. Then here we also have D11 and D7, D10 and D8. And then D9 is on the extreme end, and this is the farthest that our D can go, and this is the farthest that our D can move in the X direction. So once we are through with that, then we can use a smooth sketch to join all the C's, C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, up to C12, and you join it with a smooth curve. And then once you are sure you've gotten the right curve, then you can follow it with a finished line so that it is the only finished line that is visible. This is the answer to the question, and therefore it should be the most visible line in this diagram to show that that is the answer to the question. I hope you liked this and you followed. Please go through it, and you can go through it as many times as possible. And you can subscribe and also like this video so that to enable us to make more videos for educational purposes that will help you in your exams. Thank you, and let us meet in the next video. This is DN Kamau. Thank you.